there are various geophysical phenomena, and these phenomena, they are very important for your prelims and your mains examination. And tsunami is one such geophysical phenomena which is even specifically mentioned in the main syllabus, right? In GS1, it's mentioned like a syllabus is related with the geography, and in that it's mentioned like the important geophysical phenomena like earthquake, the volcanoes, tsunami, and the cyclones, right? So these are the important geophysical phenomena which are mentioned in your main syllabus, and for your prelims as well as mains, these phenomena, they are important. Especially, in the 2017 mains examination from GS3, right, the disaster management. Now, these geophysical phenomena which are given in GS1 is also important for your GS3, right? The disaster, the cyclone, or the earthquake, or other phenomena like flood, drought, all of these things are important for your GS3 also. So, in 2017, the mains question from disaster management was regarding the tsunami. Right, the 2004 tsunami which struck India and wreaked havoc over throughout the eastern coast as well as some part of the western coast in India. Right, this question was asked regarding the causes, effect, and the way you can manage the tsunami. So for this reason, right, since they have already asked a question for your 2017 mains examination, you can expect a question from tsunami for your 2018 prelims examination. So this question is regarding the tsunami. And before going into the question, as always, let's see the tsunami in detail. So first of all, what is tsunami and how are they formed, right? So tsunami, they are long series of waves, which impact or which wreak havoc in the coastal areas. Now they are formed, when we are having displacement of the vertical water column. In the sense, imagine this picture shows an earthquake where the crustal regions are uplifted, right? One part of the crustal regions, they are uplifted, right? Now, imagine this, if this crustal region is moving upward, it will be pushing upward the entire water column of the oceans. Now, imagine this, the huge amount of the oceanic water column is being pushed upward, right? Now, the water cannot stay like that, right? One region, the water is being uplifted, right? It cannot stay like that. It has to come down, right? Now, the entire stored energy in this amount of water is coming down, and that results in series of waves, right? And these waves, they travel throughout the deep sea and they reach the coastal regions. Their height increases and they cause, large destruction in the coastal areas, right? So tsunamis, they are caused when we are having the water column in the oceans being disturbed. Now, as in this picture, you can see that the earthquake is causing tsunami. Same way, right? A volcanic eruption, which is an undersea volcanic eruption, or an undersea landslide, or even a meteorite colliding into the ocean. All of these phenomena can cause tsunami, right? And regarding the causes of tsunami, the most important thing you have to keep in mind, all the earthquakes won't be causing the tsunami, rather than only undersea earthquake which can displace the water column will be causing the tsunamis. Imagine, if we are having the crustal regions, they are not getting uplifted, rather than they are moving parallel, right? Like transform plate boundary, right? If they are moving parallel, they won't be causing tsunami, right? The crustal regions has to move upward, which in turn causes the disturbance to the vertical water column of oceans. Only in such cases, the tsunami will be created, right? So this is how the tsunamis are created. The next, you have to understand certain characteristics of tsunami waves. Now the tsunami waves, they are high energetic waves, right? Now, be it any energy transfer, as you have seen, right? The water column going upward is moving downward, and that is transferring energy in the form of tsunami waves, right? And any energy wave, it will be having these waves, it will be having wavelength. Now this is a technical term. Wavelength means, the distance between the two adjacent crusts, or it can be the distance between two adjacent trough regions, right? Trough means depression, the crust means the ridges, right? So distance between these, we call it as wavelength. And this wavelength denotes the energy of a wave, right? Now imagine this, another property of a wave is called as wave height. That can also determine the energy of a wave. So wavelength and wave height, both of these properties of a wave, the wave height as well as the wavelength, determine the energy of the waves, or the energy determines the wavelength and the wave height. Now they are like a product, like if energy is E, the quantity will be equal to the wavelength into wave height, right? So it means that if wavelength is higher, the wave height will be less, right? Imagine a wave, imagine a wave having long wavelength, right? It will be stretched. If in that scenario, the wave height will be very less. But if the wavelength is less, right, the wave height will be higher. Okay. So imagine this. These waves, which are very high energetic waves, which are the tsunami waves, in deep sea, they travel unnoticed, right? Now, if you are in a boat in a deep sea, and if that place happens to have tsunami waves, you won't be even noticing the tsunami waves passing beneath your boat or your vessel, right? Even if you're looking through the satellite images, we won't be able to identify a tsunami wave because it is not easily distinguishable with the normal tide or normal, the waves in the ocean, right? So it means that in deep sea, they're unnoticeable because their wavelength is very high and their wave height is very less, right? And these large wavelength, waves, when they reach the coastal regions, right, they will get stacked up, right? Stacked up in the sense one wave is reaching the coastal region, and the coastal regions will be having shallow depth than the open sea, right? So, so hitting this obstacle, the waves will get stacked up, right? One wave is getting obstacled by the shallowness of the coastal region, and all the other following series of waves will get stacked up behind the first wave, so that their wavelength is being decreasing. Now, as I said, if the energy needs to be maintained a constant, right? If the wavelength is decreasing, the wave height will increase, right? Now, if I ask you to imagine a tsunami wave, you won't be imagining it as a simple gentle rise and fall in the sea. Rather, that, when the tsunami waves reach a coastal region, it's having height as much as that of 30 meters, right? It's a huge. But in deep sea, they are even a slight swell of 12 inches. In deep sea, their wavelength is very long, wave height is very less. But when they reach the coastal regions, they will get stacked up, so that means their wavelength is getting reduced. So to maintain energy as a constant, right, the conservation of energy, to conserve the energy, the wavelength as it's decreasing, to conserve the energy, the wave height will start to increase. And this is why in coastal areas, the height of the tsunami waves are increasing when they are reaching the coastal areas, and in deep sea, they are going unnoticeable, right? Now this is a property of the tsunami waves, and it's called as Schwaling effect, in the sense, when they reach the coastal areas, their height increases, and in deep sea, their height is very less. They're barely noticeable in deep sea, and they cannot be identified through satellite imaging, right? Through remote sensing, we cannot identify the occurrence of tsunami waves. Now, this one shows, due to an earthquake, a tsunami is being generated, and in deep sea, they are very gentle rise and fall of sea level, right? And when they reach the coastal areas, their height will be increased. Now, imagine, if the tsunami waves are gonna strike a port, right? Now, if the boats or the vessels there needs to be saved, right? Their best bet is to travel towards the deep sea, because in deep sea, tsunami waves, they are gentle rise and they won't be causing any destruction. But in the coastal areas, when it reaches the inland, where the depth of the ocean is reduced, right, their height will be increased to large extent, right? And during the occurrence of tsunami, right, the water will be retrieved, right? The water will be retrieved and we will be able to see the sea floor, right? So there will be change in sea level before the occurrence of a tsunami wave. Now this is a symptom of a tsunami wave, right? Now in 2004 tsunami, right, we have noticed that, before the occurrence of before the occurrence of tsunami, the sea retrieved inward towards the sea, right, exposing the seabed. And later on, like all of a sudden, the water will be, huge waves will be striking the coastal areas. Now these are certain characteristics of tsunami waves. So now let's go back to the question. The question is, which of the following takes place when tsunami waves leave the deep waters of open sea and travel towards shallow water? In the sense, a tsunami is traveling from deep sea towards the coastal areas, And which of these following will take place? That's the question, right? This is another two statement question. In the first statement, their speed is reduced considerably. Now, when a tsunami wave is traveling inward to a coastal area, as I said before, right, the waves, they will get stacked up. Now, imagine that, right? If each wave is getting stacked up, they are being obstacled, right? Their speed will get reduced. And later on, the later waves, which are following the initial waves, they're traveling with higher velocity than the initial waves, right? So, in deep sea, the tsunami can travel at the speed of even a jet aircraft. And when they're reaching the coastal areas, their velocity will be reduced. I don't mean to say that their velocity is very less. Their velocity is, if still in coastal areas, their velocity is high that it can cause huge destruction. But comparing to the deep sea, their velocity is reduced in the coastal areas when they are approaching the shallow water. So the first statement, right, their speed is reduced considerably. Now, as a fact, sometimes in deep sea, the velocity or the speed of the tsunami waves will be 900 km per hour. And when it is reaching the shallow water or the coastal areas, their velocity will be reduced to 100 km per hour, right? So there is huge reduction in velocity, but at the same time, the height is being increasing. I mean, height will be increased if they are reaching the coastal areas. Now, the second statement, right? They appear as a gentle rise and fall of the sea. I mean, the question is, the tsunami waves are leaving the deep water and they are traveling towards the shallow water. As I've said before, when they're reaching the shallow water, the wave height will increase. I mean, they won't be appearing as gentle rise or fall. So the second statement is wrong and the first statement is correct. The speed will be reduced, their wave height will increase. So the first one is correct and the second statement is wrong, and answer comes out as A, which is 1 only.